Hello, my dear students. Welcome to BYJU'S exam prep. Hope you guys are fine. So, guys, come on, join the session fast so that we can start as early as possible. Be quick. And before that, let me quickly tell you if you don't know about me, you can go through my profile. Next, you can join my Telegram group for further upcoming classes. And, guys, here is the syllabus for your foundation course of 2025. And this has been slightly changed. As I told you, this was 22nd today, and tomorrow we'll be dealing with all types of harnesses. After that, from 26th, your fluid mechanics will start regarding Pascal's law, hydrostatic, then hydrostatic forces, and then buoyancy concept. Apart from that, guys, you should know that this year in GATE 2024 we have got 30 plus ranks under All India 100. So we have got outstanding results in this 2024 GATE. Apart from that, there is a scholarship test on 14th of April. Flexibility of timing is there. You can give the test anytime between 9 a.m. in the morning to 9 p.m. in the evening. And now we'll start the session. Good evening, Kothapalli ji. Good evening. Hello, Krupa. How are you? Okay. So now we'll start the session without any delay. I guess now everybody is ready. So we'll start with the session quickly. Okay. Quick. Okay. Guys, we'll be covering the entire portion of alkalinity in today's sessions only. So try to share the session with maximum of your friends so that they can also take the advantage of it. Fine? Chale. Okay, fine. So now let's start the session quickly. First, we will be talking about what do you mean by alkalinity. So before talking about the measurement of it or the impact of it, let's first talk about alkalinity. So now this, maybe in this 1 hour we'll complete it. So all your concepts will be clear. Alkalinity, first of all, comes under the category of chemical water quality parameter. Chemical water quality parameter. Now, next, if I talk it about what do you mean by alkalinity? Generally, a basic, simple definition. You have done the test. Okay, that's good, Krupa. Now, if you talk about the basic definition of alkalinity, the basic definition which you say is ability of water to neutralize acid. Of water to neutralize acid. You call this as alkalinity. But now the question comes that how does the water got that ability to neutralize acid? You told alkalinity is the ability of the water that it will neutralize the acid. But the question comes from where does the water got that ability? So the reason is there are certain ions which are being present in water which are being capable of neutralizing the H plus ions. Acid means what? H plus ions, or you call it as hydronium ions. So you technically, you can say advanced definition of alkalinity is concentration of all the ions in water. Concentration of all the ions in water which are capable of neutralizing hydronium ion concentration. H plus ion means hydronium ion concentration. This is the basic definition. So either you say ability of water to neutralize acid, or those ions which are present in water which are capable of neutralizing hydronium ion. Now the next question comes that what are those ions? Can you tell the name? Yes. There are ions like hydroxyl ion, carbonate ion, bicarbonate ion, then you have ammonium ion, you have biborate ion. There are n number of ions are there. Okay. So HPO4 2 minus, there are n number of ions are there. All this will impart alkalinity. Okay, all these will impart alkalinity. Basically, it is the anions in water, which anions means negatively charged ions, cations means positively charged ion. Here negative sign is there, so it is trying to tell you that these are anions. Okay, so alkalinity in water is due to all these anions. But you will say, ma'am, there will be n number of anions which will be present. How we will do the calculations? So generally you will see that 99%, even more than that, alkalinity is due to only these three ions. I'm not saying that other anions does not impart alkalinity, but their contribution is negligible as compared to these ions. Okay. Now, if hydroxyl ion imparts alkalinity, that type of alkalinity you call it as caustic alkalinity. If carbonate ions imparts alkalinity, you call it as carbonate alkalinity. And if bicarbonate ion imparts alkalinity in water, you call it as bicarbonate. You call it as bicarbonate. Okay, so now whenever I'll be saying that caustic alkalinity, I will not say that alkalinity due to which minus ion is termed as caustic alkalinity. When I say carbonate alkalinity, I won't be saying alkalinity due to carbonate ion is termed as carbonate alkalinity. The moment I say carbonate alkalinity, automatically it should strike to your head that I'm talking about alkalinity imparted due to carbonate ion. When I'm saying bicarbonate alkalinity, automatically it should strike that I'm talking about alkalinity due to bicarbonate ion. Okay, now comes the question that these ions will neutralize the acid. Now there is a term which you should know, negative alkalinity. Now this is technically nothing like this is the negative alkalinity, but still you should know about it, negative alkalinity, because sometimes they ask questions from this. Now, let us suppose in the water 10 units of alkalinity is there and 4 units of H plus ion is present. Now you won't say that 10 units of alkalinity was there, so 4 units of alkalinity neutralize the 4 units of H plus ion, so the remaining net alkalinity is 6 units. No, you don't say like this. If somebody asks you, you will say that the alkalinity is what? 6 units only. Now what you did, you subtracted this H plus ion. You subtracted this H plus ion. So technically you say that that ion which does not impart alkalinity in water imparts negative alkalinity. और इसका कोई मतलब नहीं निकल के आता भाई तुमने alkalinity impart नहीं की, so you said that it imparts negative alkalinity. Okay, otherwise this is a purely hypothetical concept. There is nothing like negative alkalinity. Okay. Okay, we usually forget the reagents we have to add. So just make a table, stick it in your place, and then only you'll be able to remember it. Okay, that is the only way you can do it, Krupa. Fine. Now, negative alkalinity I told you. Now the question comes that what will be the impact? If let us suppose alkalinity is present in water, then what will be the impact of it? Impact of alkalinity, if you talk it about, the impact is, let us suppose if carbonate is present. Okay, if carbonate is present, you know in water generally calcium and magnesium is present in prominent quantity. So if carbonate is present, calcium will react with it and it will form calcium carbonate. Okay, if let us suppose aluminium is present, it will react with hydroxide and it will form aluminium hydroxide. So what will happen? What will happen is, if the pipe is there, these will precipitate out and they will be deposited. So what will be happening? Here incrustation of pipelines will happen. Sediments will deposit. And when deposition of sediments takes place, what will happen is discharge carrying capacity of pipeline will decrease. Clear? That is the impact of alkalinity. Moreover, these are what? Basically salts only. So there are chances that it can lead to hypertension, blood pressure increase. That can also happen. So these are the impacts of it. Moreover, if you want to know that in water, from where does this alkalinity comes from? So just for your remembrance purpose, if let us suppose carbon dioxide is there and it is present in water, it will form carbonic acid, which is a weak acid. Carbonic acid will dissociate into H plus SCO3, which is a bicarbonate ion. So it will impart bicarbonate alkalinity. This bicarbonate ion will further dissociate into H plus ion and carbonate ion. So now we will get carbonate alkalinity. This carbonate ion will combine with water and form bicarbonate ion plus OH minus ion. So this will give you caustic alkalinity. So what will happen in water? You will get bicarbonate alkalinity, you will get carbonate alkalinity, and you will get caustic alkalinity also. How it came? I told you. Just when carbon dioxide is there in water, you get all these types of alkalinity. Clear? Now if I move further, the next question comes is basically from where do you get this alkalinity? Okay, so it may be due to dissolved gases, okay, it may be due to organic, or it may be due to inorganic substances, inorganic matter. From where you get these alkalinity? Fine. And just check it out. Interstation, I was telling us, if there is no deposition, this much is the area available. See, the area is reduced. Even further deposition, further reduced. Even further reduced. So what you are saying, that area is reduced. Obviously, you will say, ma'am, then the velocity will increase. Correct. But the discharge carrying capacity of pipeline will reduce. Okay, discharge will not reduce. What I said is discharge carrying capacity of pipeline will reduce. Fine. Now, talking next, if I talk about that, how do you do the measurement? Measurement has techniques, like when you did about suspended solids and all. So that time the technique was gravimetric technique. Right now I'm doing the measurement of alkalinity. So here the technique is titration. Now what happens in titration, I'll tell you. First of all, there is a burette. Okay. Now generally the burette which we take is of 100 ml. You can take it of any volume. Titrant, that is a chemical which reacts with the unknown parameters present in the water sample. Now, one interview question. Generally, first they ask you the titrant. So, the titrant which we add is 0.02 normal H2SO4. What do you mean by 0.02 normal H2SO4? It means 0.02 gram equivalents of H2SO4 is present in 1 liter of the solution. Now, can I add hydrochloric acid or nitric acid? Of course, you can add any other acids also. You can take any other normality also. But taking this acid, taking this normality gives you good results. That's why we are taking it. Now, in the water, you have carbonate alkalinity present, bicarbonate present, caustic present. Okay. Now, before starting the experiment, first you should know about the indicators. Now, ma'am, what are indicators? Indicators are the chemicals which will tell you when the experiment is over, because you should know now when the experiment is over. So who will tell you that? Indicators will tell you. So there are two types of indicators which you will be using it here. First is phenolphthalein and the other one is methyl orange. Okay. Now, if I talk about phenolphthalein, the working range in which the phenolphthalein works. So, working pH range is 8.6 to 10.3. Now, if you talk about the original color of phenolphthalein, so the original color of it is, two colors are there. One color which it gets in its working pH range, and the other one is its original color. So the original color is, if you talk it about, is colorless, or you can say yellow, because they appear same only. While in its working pH range, the color is pink. This you need to remember. Okay. Slight variation in pH, you can see in different books, you can see that different pH they give you the variations, but you should know about it. Now when you talk about methyl orange, the original color of methyl orange is orange red, and in its working pH range, what is the working pH range? What is the working pH range? The working pH range is 2.8 to 4.4. In this range, it becomes yellow. It turns yellow. So these two are the indicators about whom you should know before we start the experiment. Clear? Now let's move. Now let's move about it. So now what we will do is, right now we haven't started the experiment, and we will take first assumption that the pH of water in which we are carrying out our test, here the pH will be more than 10. This is our assumption. Okay. Now if we talk about further, Firstly, we will assume that the pH is more than 10. So let me draw a graph. Here it is volume of titrant used, that means H2SO4 used, and here will be the pH. Okay, now we assume that the pH is 10 or more than that. Before starting the experiment, we added phenolphthalein. Right now we haven't started the experiment. I added phenolphthalein. The pH is 10. That means it is falling in the working pH range. So the moment you add phenolphthalein, it will become what? The color will become pink. The color becomes pink, then you will start with the experiment. What you will do, you will turn on the knob. So this H2SO4 will, what will happen to this H2SO4? This will go and it keeps on going into this water in which alkalinity is there, and what will happen? Neutralization reaction will take place. Eventually, since H plus acid is adding in this water, H plus acid is going in this water, what will happen? H plus acid is going in this water. That means pH will decrease. So from 10, the pH will go to how much? 8.3. Till this pH, you will see that the color is changing from pink. Now it changes to yellow. The moment it changes to yellow, you will turn off the knob and you will check it out how much acid is used. Let us suppose here the reading was 100 ml because you have filled 100 ml of the titrant. Here the reading is 100 minus P. That means in the first process, P ml of titrant is used. Now, what exactly happened during this time? So, what exactly happened during this time? Two things happened. Two things happened. First, OH minus reacted with this H2SO4 and it converted to water. Okay. Second, the carbonate ion which was present, it reacted with H plus ion and it formed bicarbonate ion. Now remember, this is not that bicarbonate ion which is present in water. This is that bicarbonate ion which is formed after first neutralization of carbonate ion. So for bifurcating it, I'll just mark it here at start so that you can know that this carbonate ion from which you got this bicarbonate ion is due to the reaction with H plus ion. Fine. So in the first process, you got that P ml of acid is used. Clear? Now, you have turned off the knob. Now, before starting the experiment again, see, you will not refill it. Okay, you will not refill it. So, before starting the experiment again, you will add methyl orange. Right now, the pH is what? 8.3. So, the moment you will add methyl orange, the color will become orange red because right now methyl orange is not in its working pH range. The moment it becomes orange red, now you will start with your experiment again. You will turn on the knob so that this H2SO4 again reacts and again the neutralization will take place. H plus is adding means pH will further fall down. So now the pH will fall to 4.5. And during this process, you will see that the color of the water sample has become yellow and colorless. The moment it becomes yellow and colorless, you will turn off the knob. You will turn off the knob, correct? And you will do the reading. So let us suppose it comes 100 minus M. That means M ml of, here P ml was used and here M ml of titrant is used. Now what happens from 8.3 to 4.5? Two things will happen. First, this HCO3 minus which was formed due to this carbonate ion will react with H plus and it will get converted to carbonic acid. Clear? And the bicarbonate ion which was already present. Okay. So that will also get converted to carbonic acid. Two things will be happening. Clear? And after this here, and how much acid is used in total? mml of acid is used. So after this, what will happen? Your entire alkalinity will be over. Your entire alkalinity will be over. Okay. So now your entire alkalinity is being done. So now if I make a table, which is very important, so you will see. Okay. So if I talk it about pH greater than 10, or you can say at pH of 10, what is happening? Initially all were being present. Initially all were being present. Anybody is having any doubts or what? All were being present. Okay. Now at pH from 10 to 8.3, the moment it goes to 8.3 pH, what has happened? Caustic alkalinity is completely neutralized and carbonate, half of it is neutralized. And how much acid is used? Volume of acid used is PML. From 8.3 to 4.5 pH, the remaining carbonate will be neutralized and the bicarbonate. Okay. And at pH 4.5, caustic, carbonate, bicarbonate, all will be neutralized. So total acid used, acid is same only. You are designating it as PML, MML, but that is H2SO4 only. How much acid is used? MML. So in between 8.3 to 4.5, how much acid is used? M minus P. So if they ask you PML, this is the acid used in first stage. While if you talk about MML, this is the acid used in both the stages. Now you can ask me, ma'am, that this is the acid which is used in this complete process. Now, how can I know that when it was carbonate alkalinity, when it was bicarbonate alkalinity, how can I know about it? Okay, if I want to know, how can I know about it? So let me tell you one thing. Let me tell you one thing, that there are certain values which you will get. Based on that, you will decide whether which type of alkalinity is present. Now let's move about it. First, let us suppose case 1. The volume used in first stage is also 0 acid. Volume used in second stage is 0. That means in that water, no alkalinity is present. You are not having any alkalinity. No alkalinity is present. This is the first case. Now let us suppose you did the experiment. And you found it out. Now we are going on the upgradation form. Okay. Now here you found that no acid was used in the first stage. कोई acid use नहीं हुआ. But total दोनों स्टेज मिलाकर कुछ एसिड यूज हुआ. पहले स्टेज में कोई एसिड यूज नहीं हुआ. फर्स्ट स्टेज इज व्हाट? इफ यू टॉक अबाउट फर्स्ट स्टेज, इट इज caustic and half of carbonate. If you talk about both the stages, it is OH minus plus CO32 minus plus HCO3 minus. Okay. So first stage no acid is used, means क्या present नहीं होगा? Neither caustic, neither carbonate will be present. Ma'am, why carbonate will not be present? Because if carbonate is present, some acid should have been used in the first stage, but कोई acid use नहीं हुआ. It means only bicarbonate alkalinity is present. Only HCO3 minus is present. So if they ask you this in match the following or in statement wise or in tick the correct statement question, you should be able to answer it. Good evening guys. You are late. Now, case 3 if I talk it about, so here what you will see is acid used in first stage, because P is acid used in first stage. Okay. Acid used in first stage is equal to acid used in both the stages. मतलब पहले स्टेज में जो एसिड यूज हुआ है दोनों स्टेज के बराबर यूज हुआ है. इसका मतलब दूसरे स्टेज में कोई एसिड यूज ही नहीं हुआ. अगर दूसरे स्टेज में कोई एसिड यूज नहीं हुआ, इसका मतलब ओनली caustic alkalinity is present. क्यों? क्योंकि अगर आप बोलोगे मैम why carbonate is not present, because अगर carbonate present होता, if carbonate alkalinity would have been present, तो दूसरे स्टेट में भी एसिड यूज हुआ होता. Why? Because carbonate को दो H plus चाहिए होते. First for converting it into HCO3 minus, and then other for converting into H2CO3. So if carbonate would have been present, पहले स्टेज में भी एसिड चाहिए, सेकेंड स्टेज में भी एसिड चाहिए. But here it is telling you acid used in first stage is equal to the acid used in both the stages. That means what? Only caustic alkalinity is present. only caustic alkalinity is present. तो आप देखकर just seeing the sample, you can't say that only caustic is there, bicarbonate is there. You'll get the value of PML, you'll get the value of MML, and then you will decide which type of alkalinity is present in water. Clear? Now, next, guys, if you are having any doubts, you are free to ask. There is nothing like that foundation. Now, P is equal to M by this is the one. Acid used in first stage is half the acid used in both the stages. It means दोनों स्टेज में इक्वल अमाउंट ऑफ एसिड यूज हुआ है, पहले स्टेज में भी और दूसरे स्टेज में भी. इसका मतलब दोनों स्टेज में इक्वल अमाउंट ऑफ कंसंट्रेशन प्रेजेंट है. तो ये हो सकता है, देखो, नाउ दिस कैन बी एन एमएसक्यू क्वेश्चन, दिस कैन बी एन एमएसक्यू क्वेश्चन. कैसे हो सकता है? फर्स्ट हमारा केस, ओनली कार्बोनेट एल्केनिटी इज देयर, ओनली कार्बोनेट एल्केनिटी, बिकॉज कार्बोनेट एल्केनिटी को दोनों स्टेज में H प्लस चाहिए रहता है, एक एक. इसका P इज इक्वल टू M by 2 मीन्स फर्स्ट स्टेज और सेकेंड स्टेज में सेम अमाउंट ऑफ एसिड यूज हुआ है. दिस इज पॉसिबल अगर दोनों में सिर्फ कार्बोनेट एल्केनिटी हो, OH माइनस और HCO3 माइनस एब्सेंट हो, नहीं हो. ठीक है. सेकेंड ये हो सकता है कि भाई अगर OH माइनस और HCO3 माइनस प्रेजेंट है तो दोनों की क्वांटिटी, कंसेंट्रेशन शुड बी सेम. दैट कैन बी ऑल्सो देयर. ओके, कंसेंट्रेशन शुड बी सेम एंड कार्बोनेट एल्केनिटी एब्सेंट. थर्ड केस हो सकता है, दिस इज अगेन आई एम टेलिंग यू, दिस इज एन एमएसक्यू क्वेश्चन, इट विल बिकम that OH minus and HCO3 minus is present in equal concentration and CO32 minus is also present, because CO32 minus को पहले स्टेज में भी सेम लगता है और सेकेंड स्टेज में भी सेम लगता है. So all these three conditions, only carbonate हो या OH minus और HCO3 minus हो, carbonate ना हो, और either OH minus HCO3 minus हो और carbonate भी हो, in all the cases you will get P is equal to M by 2. Okay. Now इसके बाद आप बोलोगे कि मैम जरूरी है कि या तो 0 हो, M हो, M by 2 हो, कुछ, it can't be like this. Like case 5, P is greater than M by 2. P already told you, OH minus plus half of CO32 minus, and this is OH minus plus CO32 minus plus HCO3 minus. Of course, ये भी हो सकता है. Now, it means acid used in first stage is greater than 50% of the acid used in both the stages. मतलब पहले स्टेज में ज्यादा एसिड यूज हो रहा है. इफ पहले स्टेज में ज्यादा एसिड यूज हो रहा है, पहले स्टेज में कौन है? OH माइनस है. इसका मतलब पानी में तीनों प्रेजेंट है. OH minus is also present, CO32 minus is also present, HCO3 minus is also present. But पहले स्टेज में ज्यादा एसिड यूज हो रहा है, more acid is being used. That means OH minus is more as compared to HCO3 minus. This is the meaning of it. Clear? Now, carbonate तो है, OH minus CO32 minus is there, but carbonate requires same amount of H plus in both the stages. तो उसकी तो हम कोई बात ही नहीं करेंगे. We are talking about only P is greater than M by 2, so we are talking about only caustic and bicarbonate. Case 6, last case. उल्टा भी हो सकता है. Acid which is used in first stage is less than 50% of the acid used in both the stages. इसका मतलब है पहले स्टेज में कम acid is used. If in first stage lesser acid is used, it means what? OH minus है तो पर कम. And if you'll talk to me that ma'am, out of all the stages, which is the stage in which you will means इसमें से कौन सा in which you see that the water sample prominent shows that characteristics, that is case 6. Case 6 when you just check it out that here the amount of basically you can say bicarbonate ion is more as compared to the caustic ion. Caustic alkalinity आपको generally कम मिलती है as compared to that of bicarbonate caustic alkalinity कम as compared to bicarbonate alkalinity. Clear? Now, so these are the conditions by which you can know that which type of alkalinity is present in water based on checking the titration. Titration already told you, titration is basically the unknown parameter will react. The chemical titrant is a chemical which reacts with the unknown parameter present in the water sample. Now talking about the limits of it. So you have two limits. One is your acceptable limit, and the other one is your cause for rejection limit. So generally, hardness and alkalinity both we express in terms of calcium carbonate. So acceptable limit, if you talk about, it is 200 mg per liter as calcium carbonate. And similarly, if you talk about cause for rejection limit, okay, so generally up to 200 mg per liter, if alkalinity is present, it is good. Okay. Similarly, in case when there is no alternate source available, in that case you can extend it up to 600 mg per. Clear? So in this manner, you do the titration, and in this manner, you will get the alkalinity. Clear? So here you need to remember the indicators, that is phenolphthalein and methyl orange. First, you add phenolphthalein. After that, you add methyl orange. Know where you do the refilling of it. pH may vary slightly in different books, but you need to know about it. And how can you know that which type of alkalinity is present? By checking it out, how much acid is used in the first stage and how much acid is used in both the stages. By this, you will be able to calculate. Okay, so today I have taught you the whole theoretical portion of alkalinity. Now in the next sessions, we will be dealing questions related to it also. Okay, so I guess you have any doubts, guys? And as just one thing I'll tell you more, alkalinity, as I told you, we express in terms of calcium carbonate. Generally, it is due to carbonate, bicarbonate and caustic only. So let us suppose they have given you the concentration of OH minus in mg per liter. So divided by the equivalent weight of OH minus and multiply with the equivalent weight of calcium carbonate. Similarly, if carbonate is there, concentration of carbonate mg per liter, equivalent weight of carbonate into equivalent weight of calcium carbonate. If bicarbonate ion is there, concentration of bicarbonate ion divided by the equivalent weight of. What logic I have applied is 1 gram equivalent of anything is equal to 1 gram equivalent of anything. So gram equivalence means equivalent weight hota hai molecular weight by valency. If you want, if you don't know about it, I can take a session on stoichiometry. Kindly comment, so I'll take that session also. अगर आपको नहीं पता gram equivalence and all के बारे में. And gram equivalence होता है given weight upon equivalent weight. So now what will happen? Concentration divided by the equivalent weight. This is gram equivalence. तो जितने gram equivalents OH minus के होंगे उतने ही gram equivalents calcium carbonate के होंगे. By the logic, 1 gram equivalent of anything is equal to 1 gram equivalent of any other thing by that logic. Okay? तो अगर आपको gram equivalents हटाना है, multiply by the equivalent weight of calcium carbonate. Clear? So in this manner, you can calculate the alkalinity in mg per liter as calcium carbonate. If any alkalinity is not given to you in the question, that means that alkalinity is not present. If it is not present, consider it as zero. Clear? Fine. So this was regarding the alkalinity, and now more questions and all we will deal it in the next session. But after this, we'll be solving like hardness, and then we'll take sessions in which we'll be solving questions related to both of them. Okay, so that's all for today, guys. Hope you enjoyed the session, and if you face any doubts, you're free to ask. Okay, you're free to ask to me, and I'll share my Telegram group also with you. Just wait. Okay. I'll share Telegram group also with you. And if you want, let's do one questions also. Just check it out. Now this question, this is a very good question. If you want, we can do it also. I have already taken it one question. Alkalinity of water is given to you. Alkalinity of water is given to you. Just check it out. Just a minute. I'll add one slide to it. Okay, fine. Now, in this question, Alkalinity of water, bicarbonate, carbonate, caustic, and minus. I told you na negative alkalinity. Now they have given you the value of HCO3 minus and CO32 minus in moles per liter, and they're telling you that OH minus and H plus are neglected. You don't need to calculate them; they are neglected. Then what will be the alkalinity? Now this is a very good question which is being asked. So see, they have given to you in moles per liter. Never ever you'll do it in moles per liter. You need to convert it into gram equivalents. So always remember, number of gram equivalents, this is very important, is equal to number of moles or the concentration of moles into valency. This is very important guys. अब देखो question में how much it is given to you in the question, how much it is given to you. Let us suppose I am talking about number of gram equivalents of bicarbonate. So this is 2. number of moles कितने है इसके 2 है. अभी तो मैंने HCO3 माइनस बोला ना, इसकी 1 है. कार्बोनेट के अगर मैं बोलूंगी दिस इज 2. नाउ अब यहाँ पर अगर मैं बात करूं, यहाँ पर आपको क्या दिया गया इन दिस क्वेश्चन, दे हैव गिवन यू द कंसंट्रेशन, हाउ मच 2 into 10 raised to power minus 3 moles per liter. Now valency of bicarbonate ion, valency is means you will give and you will achieve a stable, you will achieve the stability. So कितनी है इसकी valency bicarbonate ion की, how much it is there, HCO3 minus 1. So these will be the gram equivalents. Okay. Now similarly if I calculate number of gram equivalents of carbonate, valency is 2 and the concentration which is given to you is 3.04 into 10 raised to power minus 4 moles per liter में था. So this will be 6.08. These are gram equivalents. These are gram equivalents of carbonate. These are gram equivalents of HCO3 minus. 1 gram equivalent of anything is equal to 1 gram equivalent of any other thing. So how many gram equivalents of bicarbonate are there? इतने ही gram equivalents होंगे calcium carbonate के. How many gram equivalents of carbonate are there? This much will be the gram equivalents of calcium carbonate. So total gram equivalents will be 2 into 10 raised to power minus 3 plus 6 into 10 raised to power minus 4. These are gram equivalents of calcium carbonate. But I want the answer in mg per liter. तो जब मुझे mg per liter में चाहिए, so I'll multiply with the equivalent weight of calcium carbonate. और मुझे grams में नहीं चाहिए, milligrams में चाहिए. So 1 gram is equal to 10 raised to power 3 milligrams. Okay. Equivalent weight of calcium carbonate होता है 50. Molecular weight होता है 100 and valency of calcium carbonate is 2. So the gram equivalent of calcium carbonate is 50. So now solve it. $30 mg per liter as calcium. So this is a very good question because here if you know this logic, अगर आपको gram equivalents निकालना है and in the question it is giving you moles, molarity में आपको दे रखा है, या आप बोल सकते हो gram equivalents molarity into valency. तो कभी भी अगर questions में it is giving you in moles, अगर यहाँ पर pH को बोला नहीं होता neglect करने का, then you would have pH से आप OH minus निकालते and then you would have done it. फिर आपको ये दोनों भी लेना पड़ता. But since in the question they have neglected it, we are not taking it. अगर question में neglect करने नहीं बोला जाता, then you have to take it out. Clear? So this ये आपको पता होना चाहिए, then only you'll be able to solve. Clear? चलिए. So that's all for today guys, and tomorrow we'll be having a class on hardness. So this class will be also at 8:30 p.m. So don't forget to attend the session, and for more updates do subscribe to Byju's Exam Prep. Okay, thank you everyone. And guys, you know that we are having sessions on the app also, so you can download the session, link is there in the description. And we have launched full syllabus course for 25 and 26 both in English and Hindi language. For any doubts you can call on this number. And that's all for today. Thank you everyone.